day everyone, I'm Erica Jane Cicilino from BS Ed major in Mathematics, and this is my video presentation about our final requirements for our Calculus 3. So let's start. Let's answer this first example under geometric series. Find the sum of the first 5 terms of the geometric series 2, 6, 18, 54. So according to that given number, our first term is 2 and our r is equal to 3, wherein each term is obtained by multiplying the previous term by 3. So for our solution, for our formula, we use S sub n, or the number of terms is equal to a times the quantity of 1 minus r raised to n all over 1 minus r. So just substitute the value of our n, which is 5, and also the value of our a and r, wherein the value of our a is equal to 2 and our r is equal to 3. So s sub 5 is equal to 2 times the quantity of 1 minus 3 raised to 5 all over 1 minus 3. Compute the 3 raised to 5, so we get 243. So 2 times the quantity of 1 minus 243 all over negative 2 is equal to 242. So the sum of the first 5 terms of this finite geometric series is 242. Now let's proceed for our finite alternating series that consists of infinite numbers of terms. So our S is equal to a minus b plus c minus d plus e minus f. For our example, S is equal to 10 minus 5 plus 8 minus 3 minus 2. So to fix the sum, you need to add the even index terms and also subtract the odd index terms. So for our even index terms are 10, 8, and 2, and our odd index terms are 5 and 3. So 10 plus 8 minus 2 is equal to 16, and 5 plus 3 is equal to 8. Then 16 minus 8 is equal to 8. So the answer is 8. Of convergence and interval of convergence for the following power series. So wherein the given is sum n is equal to 1 infinite to n raised to n all over n times the quantity of our x minus 8 raised to n. So our solution is lim n is equal to infinity, the absolute value of 2 raised to n plus 1 times the quantity of our x minus 8 raised to n plus 1 all over n plus 1 times n over raised to n the quantity of 4 x minus 8 raised to n is equal to lim n infinity absolute value of 2n times 4x minus 8 all over 2 plus 1. Just multiply this 2 given, then it is equal to the absolute value of 4x minus 8 lim n infinity 2n all over n plus 1 is equal to 2 absolute value of 4x minus 8. Absolute value of 4x minus 8 less than 1, wherein this is a series of convergence, and 2 absolute value of 4x minus 8 greater than 1, it is the series diverges. So 8 the absolute value of x minus 2 less than 1 is equal to the absolute value of x minus 2 less than 1 over 8, and 8 absolute value of x minus 2 greater than 1 is equal to x minus the absolute value of x minus 2 greater than 1 over 8. So the radius of convergence for this power series is r is equal to 1 over 8. So the endpoints is x is equal to 15 over 8 of n is equal to 1 infinity is computed as 2 raised to n over n times the quantity of 15 over 2 minus 8 raised to n is equal to the sum of n is equal to 1 infinity to the computed 2 raised to n over n times negative 1 half na siya raised to n is equal to 2 over n times the quantity of 1 minus 1 raised to 2 all over 2 raised to n. So the product is equal to sum n is equal to 1 infinity negative 1 raised to n all over n. So our x now is equal to 17 over 8. Then let's substitute it. So sum n is equal to 1 infinity to the computed 2 raised to n all over n times 1 half is equal to, just multiply it, so the product is sum n is equal to 1 infinity 1 over n. So the interval of convergence for this power series is then x is less than or equal to 15 over 8 but less than to 17 over 8. Now let's proceed to the example of Maclaurin series, wherein let's find the Maclaurin series of sin 2x, wherein we use the format sin x is equal to the summation n is equal to 0 up to infinity negative 1 raised to n x raised to 2n plus 1 all over 2n plus 1 factorial. We will substitute it to become 2 sub x. In doing so, our step 2 will become summation of n is equal to 0 up into some infinity negative 1 raised to n. Now the x will become 2x and all of them will be raised into 2n plus 1 all over 2n plus 1 factorial. Well, this is enough already for the answer. Now let's proceed to the example of Taylor series. So let's determine the Taylor series of the function f of x is equal to e to 3x whose center at x is equal to 4, wherein we use the format of Maclaurin series of the given equation, which is e of x is equal to the summation of n is equal to 0 up to infinity of x raised to n all over n factorial. So by distributing the exponent, and we would clearly say that summation n is equal to 0 up to infinity of 3 raised to n. All x must be shifted of 1. If we equated the center of x is equal to 4 to 0, it will become x minus 4 is equal to 0. In other words, to will equate the center of 0, then all the value of x shifted will be up to that equation. So we need to substitute the center of the given example. So we get the answer summation of n is equal to 0 up to infinity of 3n of the quantity x minus 4 raised to n e raised to 12 all over n factorial. So that is the Taylor series of the function of f of x whose the center at x is equal to 4.